Okay, let's get into this. You've got your own info, could be documents, maybe live data feeds, and you want your AI models to actually use it. How does that connection really happen?
Right. We've been looking at some sources like parts of connecting data to AI models and the AI data connection guide.
And the sources seem to pretty clearly point to two sort of main strategies. They call them the file method and the data method.
That's right. Two distinct paths.
So let's start with the file method. This sounds like it's mostly for when you're working with, well, files, documents, right?
Exactly. Or even things like slide decks, sometimes spreadsheets, but where you're treating them more like unstructured text.
And the key technique here is something called RAG.
Retrieval augmented generation, yeah, RH. The basic idea is you take your file, your document, and you break it into smaller bits of text, chunks.
Little pieces.
Right. And each little piece gets turned into basically a string of numbers, a vector embedding. Think of it like a mathematical fingerprint that captures the meaning of that text chunk.
A fingerprint, okay. And these fingerprints, they go somewhere specific.
Yep. Into a special kind of database called a vector database. Now, here's the clever part. When you ask a question, the system takes your question, turns it into one of those vector fingerprints too, then searches the vector database to find the text chunks whose fingerprints are most similar to your question's fingerprint.
So it finds the relevant bits.
Precisely. It retrieves the original text for just those few, most relevant chunks. And then this is important, it sends only those few relevant chunks, plus your original question to the large language model, the AI, to generate the answer.
Ah, I see. So you're not overwhelming the AI with like a 100-page PDF. You're just giving it the paragraph or two it probably needs. Large collections of documents.
Makes sense.
It's very efficient for that kind of text-heavy scenario.
Okay, shifting gears then. What about data that's already structured? Like tables in a CSV, or data coming from an API, or maybe even a database query. That's the data method, I assume.
That's the data method. And the core mechanism here is different. It relies on something called a tool call.
A tool call.
Yeah. Basically, at the moment you ask your question, the AI figures out it needs data from one of your connected sources. It then issues an instruction, the tool call to the system saying essentially, hey, go get me this specific data now.
Okay, so let's take an example. I connect a CSV file, maybe sales data. What happens when I ask a question about it?
Well, with a standard CSV connection, the AI sees your question, sees the connected CSV. It issues a tool call to effectively load the CSV. The system reads the file.
And then typically the sources say the full contents of that CSV get loaded and passed right into the AI's working context. It's prompt for it to answer your question.
Wait, full contents. What if my CSV is huge, like, 100,000 rows? That seems like a lot to stuff into a prompt.
And that's a really critical point the sources bring up. They mention a threshold, maybe around 50,000 rows or so, sending the entire data set for really large CSVs.
Well,
It can be slow, expensive, or maybe just not work well.
so what do you do then?
That's where another connection type within the data method becomes super useful, the union connection.
Union. Okay, tell me about that.
So a union connection lets you set up a query beforehand. You might describe what you need in plain English, like show me total sales per region from the big sales CSV.
So I define the aggregation or filtering I need.
Exactly. The system translates that into something like an equal query, the sources mention SQL8 compatibility, and saves it as a union data set. Now, when the AI needs this data to answer a question...
And uses a tool call again.
Right. But this time, the tool call runs your predefined union query. And here's the crucial difference. Only the results of that query, the aggregated numbers, the filtered rows, whatever you defined, get passed to the AI.
Ah, so instead of sending 100,000 raw rows, you send maybe 10 rows of summary data.
Precisely. It's much more efficient for large data sets and ensures only the necessary, possibly summarized information hits the AI prompt. This is what the sources recommend for those big CSVs or when you only need aggregated views.
That's a really important distinction for performance and, I guess, cost, too. What about APIs? Like pulling data from an external service?
Similar idea with the tool call. The AI knows about the API you've connected. When needed, it issues a tool call to invoke the API, maybe passing some parameters. The system makes the actual API call, gets the data back, usually JSON or maybe a table format.
And gives that to the AI.
Exactly. The data returned by the API is what the AI uses to build its answer.
And the AI can do this multiple times for one question, right? Like hit a union query, then call an API based on those results.
Yep. It can chain these tool calls together, Fetch from a CSV, then maybe use that to query an API or combine results from multiple unions. It orchestrates getting the data it needs from the different sources you've connected.
Okay, this makes sense. Now, one more really key thing mentioned is this configuration option called data talk. It sounds fundamental.
It really is. It controls what actually gets sent into the AI's prompt from these data method connections, the
Yeah.
CSVs, APIs,
How
unions.
does it work? What's the default?
Data talk is on by default. And when it's on, the full raw results obtained from the tool call, whether that's the full CSV content, the full API response, or the full union query result, are sent directly into the AI's prompt. The AI literally sees the raw data.
Okay, and if I turn data talk off,
Big difference. If data talk is OFF, the raw data fetched by the tool call stays internal to the system. It's loaded. It might be used to generate, say, a chart or a summary statistic that the AI can see.
but the actual rows of data.
The raw rows themselves are not put into the AI's prompt. The sources are quite clear. Turn data talk off if you're dealing with sensitive raw data that you absolutely do not want ending up in the AI model's context window, maybe for privacy or security reasons.
Wow, okay, that's a crucial control. So let's quickly recap the main paths we've discussed.
Sure. You've got the file method using ENG. This is about breaking down documents, using vector embeddings, and smartly sending only the relevant text chunks to the AI. Great for documents.
Right, and then the data method, which uses these tool calls at runtime to fetch data from structured sources like CSVs, APIs, or those union queries.
Exactly. And within that data method, the key things to grasp are standard CSVs might send all the data, which is tricky for large files. Using union lets you send just pre-aggregated or filtered results, which is much better for large data.
Okay.
And then data talk on versus off determines if the raw data itself goes into the prompt or if it stays internal. These are your main levers for performance, cost, and especially data privacy.
It really highlights how much control you have or need to have over what the AI actually sees. So thinking about that difference, sending raw data versus just sending tool results or aggregated data, what new questions does that make you think about regarding privacy or maybe even performance when you connect your own information to these powerful AI systems?